My dear students, today I will bring very important topic for you. The topic name is linear momentum. So if you observe NEET and JEE examination, either advanced examination or mains examination, the topic is very important. The topic name is linear momentum. See here, linear momentum means simply what I am doing here. We know velocity vector. This is the velocity vector V bar. Now what I am doing here, simply now I am doing marriage with mass. I am doing marriage with mass here. So what happened? The product of mass and velocity is called linear momentum. So here linear momentum and velocity both are same direction. That means velocity vector direction, linear momentum vector direction both are same. Why? Because of here mass is the scalar quantity. Okay. Next. So what is the units here? Units. Mass is measured in terms of kg. Velocity meter second inverse. Next. Dimension formula. If you observe dimension formula, here mass kg is measured for mass, meter for length and second for time. Next, here momentum is a vector quantity. So here this is the vector and this is also vector. So that means momentum is a vector. Momentum is a vector. While solving the problems based on momentum, you should be follow vector laws. That's why I told you it is a vector quantity. Next, so how to solve the problems based on linear momentum? See here. If you observe previous examination questions and JEE and NEET examination point of view, they ask change in momentums. Okay. See here, before I start, I will tell you some important formulas. That first one, according to Newton's second law, external force is directly proportional to the rate of change of momentum. Next, impulse J equal to the product of large amount of force acting in small interval of time. So this is the formulas is important while solving the problems. Okay. See here how to solve the problems based on this concept. So linear momentum formula, P bar is equal to mv bar. These three formulas important here. Okay. First one, see here. First example I will take here. So here I take one wall. Next, I throw the ball with initial velocity v. Toward the wall. So ball is moving like this. Now ball and wall collide elastically. That means no loss of energy. So here initial speed and final speed both are same. Angles also same. So that means we called elastic collision. So here after collision what happened? That ball is moving backward direction with the same speed. Okay. Now they are asking question, what is the change in momentum? What is the change in momentum? See here, when ball is moving toward the wall, so I consider minus. Why? Because of here distance decreases. So here when distance decreases, I consider negative sign here. This is the minus v. Next, in this situation, when ball strikes the wall, again rebounds with same speed. When distance increases, I take here plus. So when ball is moving toward the wall, I take minus. When ball is moving away from the wall, I take plus. Okay. Now they are asking question, what the change in momentum? Okay. Change in momentum. Okay. See here, change in momentum means delta P that equal to final momentum minus initial momentum vectors. Okay. Now I am taking magnitude only, so that means delta P is equal to P2 minus P1. So delta P equal to, here momentum can be written as mass into velocity minus mv1. So delta P equal to mass can be simply, so see here v2 can be represents v mv minus of minus plus, here minus v1 is nothing but minus of minus plus. So change in momentum equal to 2mv. Okay. In which direction the change in momentum is away from the wall? Change in momentum away from the wall. So how to know here? That means if you observe here, toward the wall I take minus, away from the wall I take plus. So here change in momentum I got plus here. So that means change in momentum, so delta P is equal to 2mv. Next, sometimes they ask question, how much force acting on the ball? How much force acting on the wall due to ball? So here that means, so here F is equal to, so dP by dt. If anybody asks how much force exerted by the ball on wall, so on that time, so F is equal to dP by dt can be written as, here what is the change here? Simply I can write here 2mv by dt. Okay. So here this is the basic formula. Is it right? So I will explain one more concept. See here. Next. Second example. Example 2. This is the smooth surface. A ball is projected at an angle theta with the normal. It rebounds same angle and same speed at an angle theta. Now they are asking question, what is the change in momentum? See here. Simply I will tell you shortcut tricks. My dear students, I will tell you all shortcut tricks only. See here. Next, in this situation, I throw the ball with speed is v at an angle theta with the normal. After rebounds, it makes same speed v. Next, here I will resolve this velocity vector resolve into two components like this. So here it makes angle theta. This is also makes angle theta. What about this component? I will tell you one more important concept here. Which component makes angle theta? That component always cos theta. Okay. Next. So remaining component is v sin theta. Next. Here also if you observe here, see here. So this is the theta. So this is also theta. I told you which component makes angle theta. That component simply cos theta. Next, what about this component here? This is the v sin theta. Okay. Next, if you observe very carefully here, so here this velocity consider v1 along y-axis downward direction. This velocity y-axis positive y-axis. This is the negative y-axis. Why? Because of myself I consider when ball is moving along the negative y-axis, I represents negative. Earlier I told you when distance is decreases, I take minus. When distance increases, I take plus. What about x component? There is no change in velocity. That means these two cancel. Okay. See here. Along y-axis, I observed only y-axis. Why? Because of along x-axis no change. Only y-axis we observe changes. This is the downward, this is the upward. Downward minus, upward plus. Okay. So if you observe here, change in momentum, delta P is equal to, so simply P2 minus P1. Okay. So if you observe here, I take only magnitudes. So simply delta P equal to P2 can be represented. See here, this is the V1, this is the V2. So M V2 minus M V1. So delta P equal to M V2 can be written as V cos theta. Minus of minus plus. So this is the MV cos theta. So finally you will get, if you added these two, 2mv cos theta. So this is the change in momentum formula in elastic collision concept. Next, if you observe what is the direction of change in momentum, if you get plus here, that means change in momentum is away from the ground. Away from the ground. Okay, see here. Next, I will take one more example. Next, see here. Third example. So third example, see here, this is the ground. I will throw the ball with initial velocity u at an angle theta. Next, during the time of flight, that means during the time of flight means in xy plane, this is the x-axis, this is the y-axis. In xy plane, so here if I throw the ball, finally after t seconds, it reaches the same point, same plane. In x plane, it will reach as the same plane. Now here very important. So here initial velocity u, magnitude u here. I take magnitude v. So after that what happened? It is also having same magnitude u, but opposite direction. So if you observe here components, this is the x-axis, simply I resolve components. So simply I will write here, this is the v1 is equal to u cos theta. Here u makes angle theta, this component is u cos theta. So in this direction, so here v1 is equal to u sin theta. Next, if you observe here in this situation, if you observe here, what happened? So I will resolve two components again. So this is the theta, this is also makes angle theta with same speed. So if the velocity, it makes angle theta, this component v2 equal to u cos theta, Next, in this situation, what happened here? So v2 equal to u sin theta. They are asking question, change in momentum. So along x-axis, no change. Along x-axis, no change, leave it. Now along y-axis, initially it has plus u sin theta. Finally, it has minus u sin theta. Why? Because of in this direction plus, in this direction minus. Okay. Now they are asking question, change in momentum. So delta P equal to, so what is the formula? P2 minus P1. I take magnitudes only. So delta P is equal to, so here M V2 minus M V1. So delta P equal, this value can be written as So here m minus u sine theta minus m v1 value u sine theta. So if here minus and here minus, if you added this value minus 2 mu sine theta. Okay. So what is the meaning of here minus value? That means change in momentum is acting downward direction. Previous cases, change in momentum acting away from the rigid support or ground. But in this situation, so ball is moving even the upward direction, but change in momentum is downward direction. You should simply remember this very important concept. Next, I will tell you one more concept. Let's see here. Example 4. If you observe example 4 here, this is the rigid support. I take one water pipe. That water pipe eject the water with constant speed V. So this is the water. Okay. Now, after it elastically rebounds with same speed. With the normal, it makes angle theta. This is also makes angle theta. Okay. Now they are asking question, what is the force exerted by the water on wall? The force exerted by the water on wall. Okay. So here in this situation, so how to calculate? Okay. See here in basic classes, this is the water pipe, area of cross section A. Water ejected from the tube. Per second, you got this much of water, it travel x distance in dt time. In dt time, how much water came from the water pipe here? This much of water. Okay. That value simply dm. Is it right? This much of water came outside. So once you see here, mass can be written as volume, that means dV into density. Okay. So dm can be represents volume can be written as area into dx, density. So now you remember this formula, dm equal to a dx, small change in length dx in dt time. This is the density of the water. Okay. So my convenience, simply I consider, so here mass m equal dm, I represented by m a dx rho. Only representation only. Okay. Now they are asking question, how much force exerted by the water on wall? See here. Next, first you calculate change in momentum. So what is the change in momentum? Change in momentum. Okay. See here, in this situation, water is moving in this direction. So here again, I result two components in this direction. This direction it make angle theta. So when water is moving toward the wall, so V1 is equal to minus V cos theta. So in this situation, this is the V sin theta. Okay. Next, if you observe here, this is the velocity of the water after rebounds. So I will resolve into two components. It makes angle theta and this is the velocity. If you observe here, this is the V, this is the V cos theta. So V2 is equal to V cos theta. This is the V2 is equal to V sin theta. Okay. So if you observe very carefully, y component both are same, v sin theta along y axis, no change. But where you observe changes here along x axis. So that means you should be calculate change in momentum along x axis. Along x axis. Change in momentum delta P is equal to P2 minus P1. So if you observe here, delta P is equal to P2 value, if you observe here, this is the M V2 and M V1. So delta P is equal to M V2 can be written as V cos theta. So here minus of minus plus V cos theta. So here this is the M. So delta P is equal to 2 M V cos theta. Okay. What they asking question here? How much force exerted by the water on wall? So according to Newton's second law, F is equal to dP by dt. So F is equal to change in momentum we calculated here 2m v cos theta. So mass can be written as volume into density. This is the velocity. So F is equal to and here I will write delta T. So 2 into volume. So simply volume is directly I am writing here. M can be represents here A, M value A. This is the dx rho v cos theta. See directly earlier, first I calculated here mass A equal to area of the tube. This is the area of the tube. So here dx in dt seconds, this much of water displacement of the water, density of the water divided by dt. So F is equal to 2a dx by dt can be written as velocity rho v cos theta. So force F is equal to 2a v square rho cos theta. So this is the force exerted by the water on wall. What is the formula here? F is equal to 2a v square rho cos theta. Okay, next one more example. One more example. See here, I take one L shape water tube. So water, example 5. The area of cross section A, uniform area of cross section A. This is also A, that is also A. Okay, represented by small a. Okay. Now water enter into the tube. Enter into the tube. Okay. See here in this situation. So what happened here? When water strikes on the surface of the tube. So after rebounds what happened? Water is moving in this direction. In this direction. Okay. So if you see here change in velocity, how to write here? So that means V2 minus V1. So in this situation, this is the V2, this is the V1. So change in velocity, so here this is the V2, this is the V1. So resultant is acting in this direction. So resultant is acting in this direction. This is the change. This is the change. So change in velocity. Change in velocity. So how to calculate change in velocity? According to vector notation, I use here change in velocity. Change in velocity delta V is equal to V2 bar minus V1 bar. Okay. See here in this situation, both are has same magnitude. So how to write delta V is equal to square root of V1 square plus V2 square plus 2 V1 V2 cos theta. Okay. So delta V is equal to this value cos 90 is 0. So final I will write here V square plus V square. Same magnitude but different directions. So change in velocity equal to root 2 V. Next. So both sides what I am doing here, multiply with mass. So mass delta V is equal to root 2 mv. So this is the change in momentum equal to root 2 mass. Earlier I told you mass is equal to A dx rho. A dx rho. So here that value substitute here A dx rho into V. Now they asking question, how much force exerted by the water on tube? So that means according to Newton's second law, so F is equal to dP by dt. Now this value substitute here, F is equal to dP value can be written as root A. So here dx can be represented simply dx, small change here dx rho V by dt. The rate of change of displacement is called velocity. So simply represented by V. So force F is equal to root 2 A V rho V. So F is equal to root 2 A V square rho. So this is the basic important concept based on the change in momentum. Thank you my dear students. I hope on you enjoyed your today my classes. Okay, thank you. Once again, I will meet with new concept and very important concepts. Thank you, my dear students. Thank you. Have a nice day.